Alright, welcome. For this one, we're going to do question number 4.34, which is, an oil tanker's engines have broken down, and the wind is blowing the tanker straight toward a reef at a constant speed of 1.5 meters a second. When the tanker is 500 meters from the reef, the wind dies down just as the engine gets the wind dies down just as the engineer gets the engines going again. The rudder is stuck, so the only choice is to try to accelerate straight backward away from the reef. The mass of the tanker and cargo is 3.6 times 10 to the 7th of kilograms. Write that down. And the engines produce a net horizontal force of 8 times 10 to the 4th newtons on the tanker. Will the ship hit the reef? If it does, will the oil be safe? If the hull can withstand impact at a speed of 0.2 meters a second or less, ignore the retarding force of the water on the tanker's hull. This is a big problem, but we're going to get through it, so don't worry. So for the first part, will the ship hit the reef? Well, we're going to use the formula force equals mass times acceleration. So, we're going to try to find the acceleration. So that would be acceleration equals force divided by mass. So that would be 8.0 times 10 to the 4th divided by 3.6 times 10 to the 7th. Do that, you'll get 0.00222 meters a second squared. And that's going away. So now we're going to find the distance. We're going to use the kinematics equation for that one. So that would be, we're going to use final velocity squared equals initial velocity squared plus 2 acceleration distance. So we're going to solve for distance here to see if the tanker will hit the reef, which is this right here, 500 meters. That's the reef right there. So we're going to we can rewrite this as d equals final velocity squared minus initial velocity squared divided by 2a. And then we know that our final velocity is 0, so we have our initial velocity of 1.5. And we know our acceleration here. So if you punch those in, you'll get that our distance will be 506 meters. Guess what? 506 is bigger than 500. So yes, it will hit the reef. Oh no. But we still want to know, will the oil be safe? Because the hull can withstand impact at a speed of 0.2 meters a second or less. So what we can do is we're just going to use this equation right here, because now we have a final velocity of 0.2 meters. So if you plug in 0.2 meters, or not 0.2 meters, plug in 0.2 and 1.5, and 2 times our acceleration, which was negative. Well, in this case, acceleration is negative, same as we did before, it's 0.00222. Plug those in, you'll get 498 meters. So going at 0.2 meters a second, hull will be safe, because at 500 meters, its final velocity will be less than 0.2. So yes, it will withstand the impact. It will hit, but it might be okay.